Okay, so basically in this video I'll be retaking the pneumatic circuits which were completed in class, but as many of you were absent for these lectures, I'll be like trying to explain it to you once again through these two videos. I will be covering this one, A plus B plus A minus B minus, and the 16 question, A plus B plus B minus A minus. I will go into depth for this question. I will teach it quite long. It might be a half an hour video. But if you understand this completely, this question will be pretty easy for you. So no problems about that. This might be completed in like just 10 to 12 minutes. Okay. So see if you can means completely understand this question properly. You might not even have to watch this video completely. Okay, so first of all, let us read the question. Develop the pneumatic circuit with cascading for the following pneumatic piston movement: A plus B plus A minus B minus. If you have seen the previous question papers, the question is generally on electro-pneumatic circuit. But because to understand electro-pneumatic, it is first important to understand pneumatics. So for your UT1, it is only about pneumatic circuits. You will be moving on to electro-pneumatic after this, in the first lecture after your unit test. Okay, so first of all, whenever you start this question, whenever you start a pneumatic circuit question, you have to look at the question first. So what does A plus B plus A minus and B minus mean? Okay, so first of all, A and B represent two pistons or two cylinders, pneumatic cylinders. Okay, so A plus C, both of them, A and B, are two double acting cylinders. So this is basically cylinder A and this is basically cylinder B. Okay, so I'll delete cylinder B for now. This is cylinder A. Now A minus means that the cylinder is in the lowermost position, that is you had an IC, bottom dead center. A plus means the piston is in top dead center position. Okay, so if you have a compressor over here and you have an exhaust over here, okay, and if we simulate this, this is the A plus position and this is the A minus position. Okay, so this is A minus, this is A plus. Similarly, it will be for your B cylinder over here. Okay, so that is what is meant by A plus B plus A minus B minus. Means what should happen? A cylinder should come out first, then B cylinder should come out, then A cylinder should go back, then B cylinder should go inside. Sorry, piston. A piston should come out, B piston should come out, A piston should go in, B piston should go in. That is what they want. Pneumatic circuits are quite important in industry itself. Okay, so it is quite good if you understand them right now. Okay, so as you see in this question, there are two piston cylinders that we require, cylinder A and cylinder B. So whenever you start drawing this circuit, the first thing that you should do is see the number of pistons or number of cylinders that are required. Okay, then afterwards write them down. Okay, so I will write it over here. First is A plus, then B plus, then A minus, B minus. Okay, so this is what our question is. Okay, I made a mistake, just a minute. A plus, B plus, A minus, B minus. Okay, so this is basically our question right now. Okay, so first of all, A plus should happen, then B plus, A minus, then B minus. The first thing while you are solving this circuit, as you can see in the question, it is written cascading, with cascading. So for cascading, the first step that you should do is divide this entire list into groups. Now the rule for the group is such that each group should have one alphabet only once. Each group should have one alphabet. Each group should have each alphabet only once. What does this mean? Now see, for example, okay, before this there is no group. So this is where our first group will start. In this first group, what is the first alphabet? It is A. Okay, so A is coming once. After that B. Okay, so A has come once, B has come once. Okay, A once, B once. But look over here. A is coming the second time. Okay, but what is the rule? Each group should have each alphabet only once. So this cannot be in the first group. So you'll have to make a group over here. You have to break it because this alphabet cannot be repeated in the same group. Okay, so this becomes your group 1, and from here on onwards your second group is starting. Okay, now let us check if there is any repetition in this group. See, there is first A. Okay, so A is coming once, then B minus, B is coming once. After that there is nothing. Okay, so this group ends over here. This becomes your group 2. So basically in this question you have two groups, group 1 and group 2. Group 1 has A plus and B plus, group 2 has A minus and B minus. All the questions that you have in your exam will generally consist of maximum two groups. Very rarely it is possible that there might be a three group question, but it hasn't come in the university papers ever. Okay, so don't worry about that. Concentrate on these two group conditions. So this is your group 1, this is your group 2. Okay, so you have divided it into two groups. Okay, your first step is over. Now let us go to the circuit part. Okay, so what is the total number of piston cylinders that you require? A and B. So you require two pistons and two pistons or two cylinders. So take your first cylinder. They have to be double acting. Okay, you cannot take a single acting cylinder for these questions. They always have to be double acting cylinders because you need both the positions, plus and minus. Okay, so this is your minus position, and when the piston comes outwards, that will be your plus position. Okay, so the first thing that you must do whenever you place these two cylinders is draw limit switches. So what are basically limit switches? Okay, you can see this, I have explained it in class, but let's see once again. A limit switch is basically a mechanical switch that is automatically operated using a piston. So when the piston comes outwards, okay, when the piston comes outwards, it pushes this panel down. This arm is pushed down, because of which this push button gets pressed. Now this is a type of an electrical limit switch. See, you can see electrical points over here. In pneumatic circuits, we don't use electrical limit switches. We use pneumatic limit switches. For example, this one. If you can see over here, okay, I will show you this photo. Yeah, this is a pneumatic limit switch. See, it is just like a 3 by 2 valve. Okay, now if you don't even know what a 3 by 2 valve is, you will have to read it somewhere. Okay, so basically this is a 3 by 2 valve. Okay, what this valve is saying, always remember the first port is always connected to the compressor. Compressor is providing the air, and the third port is always connected to the exhaust, and the second port is your outlet. Okay, in this position the outlet is connected to exhaust, so no air is going out from here. But in this position, if this position is activated, what is going to happen? Air from the compressor is going to come over here, that is over here. It is going to pass right to the outlet. So that is basically what is happening over here. When the switch is not pressed, when the switch is not pressed, the air from the outlet, okay, this is upside down diagram. So this is your outlet, these two are your inlets. So this will be your port number, this will be port number 1, this will be port number 3, this is port number 2. So when it is not pressed, sorry, this is port number 1, this is port number 3, this is your output. When the switch is not pressed, what is happening? Air is going directly to the exhaust. When the switch is not pressed, air is directly going to the exhaust. Okay, but as soon as this switch is pressed, air from the compressor comes out as exhaust. Okay, air from the compressor comes out. This is your limit switch. So limit switch basically provides us with air, a small amount of air which is enough to switch the circuit. Okay, so whenever this switch is pressed, the position is changed. Whenever this switch is open, it is in its base position. Okay, so that is what we are going to use in our circuit also. Now we need limit switches. Now what are the positions that we are interested in? Okay, what are the positions of the cylinders that we are interested in? We are interested in A plus, B plus, A minus and B minus. These are the four positions that we are interested in. So A plus, as we all know, A plus means completely out, A minus means completely in. So for that we are going to use this distance ruler. So A minus, let us put a sensor known as A0 to indicate A minus position. So it is at 0% outwards. And let us put a sensor known as A1 which shows that the piston is 100% out. Okay, A0 is showing it is completely in, A1 is showing that it is completely out. Similarly, we will do for this also. I'll put one over here. B0 completely in, B1 completely out. Done. So what we have done basically is we have put four limit switches, four pneumatic limit switches at the four positions. These four pneumatic switches will tell us whether the piston A is completely inside or completely outside, and whether the piston B is completely inside or completely outside. Okay, so this part is done. So now we have to drive this double acting cylinder. A double acting cylinder always has two inputs. As you can see, this is input 1 and this is input 2. So whenever you want to operate a double acting cylinder, you will need a direction control valve which has at least two outputs. Again I am repeating, whenever you want to operate a double acting cylinder, you will need a direction control valve which has at least two outputs. Okay, so the valve which you saw just now, 3 by 2, it has only one output. It has two inputs but it has only one output, so it cannot be used in this case. So what are the other options? You can use either a 4 by 2 valve or a 5 by 2 valve. See, a 4 by 2 valve also has two outputs. It has two inputs and two outputs. A 5 by 2 valve has three inputs and two outputs. Actually, you can use either one of these. If you use this also to make this entire circuit, no problem. But generally in exams, you are always asked to use a 5 by 2 valve. So in this case, we will use a 5 by 2 direction control valve. Okay. So for this cylinder A, okay, let us name the cylinder. This is your cylinder A. Similarly, this is your cylinder B. Then for cylinder A, we will require one 5 by 2 volt. Similarly, for cylinder B, we will require another 5 by 2 volt. Okay. So connect the left side to left side, right side to right side. Left side to left side, right side to right side. Done? No, we are not done yet. Always remember, where is number 1 connected? Number 1 is always connected to the compressor. Number 1 connected to compressor. Where is 3 and 5 connected? Exhaust. 3 and 5 connected to exhaust. Okay, so the valve is done, but how are we going to change the positions? Something is required to change the position. Now, just have a look at the question. Pneumatic circuit. The question is pneumatic circuit. Whenever the question is pneumatic circuit, you always have to use pilot control direction control valve. Again I repeat, whenever the question is pneumatic circuit, you have to use pilot controlled direction control, pilot operated direction control valve. What does pilot operated mean? Okay, pilot operated means a small amount of air is used to change the position. Okay, so what is the symbol for this? This is the symbol for pilot operated. Okay, so pilot operated direction control valve. That is what we have drawn over here for cylinder A and cylinder B. Okay, so this part is done. Now again go back to this part. Okay, so see, it starts with A plus. A plus means the piston will completely come outwards. After that, what is going to happen? After that, B plus is going to happen. B plus means the piston B will come completely outside. But how will the piston B know that it has to move? It has to be told that it has to start moving outwards. And when will it start moving outwards? Only when the piston A has completed its outward motion, right? The piston B will start moving outwards only when the piston A has reached the A plus position. But how will we know that the piston A has reached the A plus position? That is why we will use the sensor A1. A1 tells us that the piston A has reached the outermost position. Okay, understood? Sensor A1, the pneumatic limit switch A1 tells us that the piston has reached A plus position. Only then B plus should happen. So whenever you are going from A plus to B plus, what sensor are you using? You are using sensor A1. Okay, you are using sensor A1. Now when you are going from B plus to A minus, how will A piston know that it has to start moving inwards? It will know only when the piston B has reached its B plus position. That is, the piston B has come completely outwards. Only after that the piston A shall start moving inwards. So whenever the piston B completely comes outwards, which sensor will be activated? Which pneumatic limit switch? B1. Okay, so B1 will be activated. So from B plus to A minus, it is B1. Similarly, how will piston B know that it has to start moving inwards to go to B minus position? Only when the piston A has reached to its innermost position. That is, it has reached to A minus position. Only after the piston has reached to its A minus position will B piston start moving. But who tells the controller that A minus position has been reached? It is this sensor A0. A0 will tell us that the piston A has reached A minus position and piston B should start moving inwards. That is why B minus will happen only when A0 sensor is sensed. Similarly, as you might have guessed, how will A plus know that it has to start moving again? It will know only when, just a minute. Okay, yeah. Okay, so again, if this cycle has to continue, after B minus, A plus should start again, right? But how will A plus know that it has to start all over again? It will only know when B minus has been completed. And how will we know that B minus has been completed? Because sensor B0 will be activated. So from here to here, it will be B0. B0 sensor will tell us that A plus should happen now. But this is not the right way of drawing it. Okay? Because this is a huge loop. So rather than drawing it like this, we draw it like this. Okay? See, this diagram is very important You have to draw this diagram in your final exam or even in your exam tomorrow. There should be arrows over here. I can draw it easily in paint. Okay, so this is what your basic diagram should look like. Complete diagram. Okay, now see what is the total number of sensors that we have used. 1 B0, 2 A1, 3 B1 and 4 A0. Then again B0 is repeated. So the total number of sensors used is 4. Now you can see that some of the sensors, for example B1 and B0, are going from, see for example let us look at B1. B1 is starting in group 1 and going to group 2. That is, B1 is crossing over a group. It is changing from this position to this position. It is going from group 1 to group 2. Similarly, look at B0. It is starting from group 2 and going into group 1. So even it is changing its group. Such sensors which cross a group, which go from one group to the other, are known as lower level sensors. The sensors which cross from one group to the other are known as lower level sensors. And the sensors which do not cross over a group, for example look at A1 or A0, it is saying in the same group, it is starting from group 1 and ending in group 1. Look at A0, it is starting from group 2 and ending in group 2. Such kind of sensors are known as higher level sensors. So higher level sensors and lower level sensors. The sensors which cross from one group to the other, like B0 or B1, which go from one group to the other, are known as lower level sensors. Which is the first lower level sensor? B0. So B0, which is the okay. Next sensor is A1. A1 is staying in the same group, so it is a higher level sensor. Next is B1. B1 is going from group 1 to group 2. So it is a lower level sensor. And A0. A0 is staying in the same group. So it is a higher level sensor. Okay. A1, A0, B0 and B1. Okay. So we have the levels of both all the four sensors. Now we will draw them in our circuit. We have a total of 4 sensors. Now just as I showed you in this picture, pneumatic limit switches or pneumatic limit switch sensors are always 3 by 2 valves. 3 by 2 valves, limit switch operated, spring return, 3 by 2 valves. So we will use 3 by 2 valves. What kind? Limit switch operated, spring return. Okay, and how many we need? We need 4. So we have 4 of these. Sorry, we have these 4 limit switches: A0, A1, B0, B1. So we'll name them A0, A1, B0, B1. See, you can see A0 and B0 are already active because the piston is at A0 position and the piston is at B0 position. Hence, these two are already active and these two are not active because the piston is not in this position. Okay. So, what do we have to do next? The higher level sensors, as the name suggests, are at an higher level, and the lower level sensors, as the name suggests, are at a lower level. So which are the higher level sensors? A1 and A0, and the lower level B0 and B1. So put the higher level sensors up, put the lower level sensors down. Okay. Again, check which is the first lower level sensor, B0. So the first lower level sensor will be to your left side and the second lower level sensor will be to your right side. First lower level sensor to left side, second lower level sensor to right side. Then put the higher level sensors in any way you want. You will come to that afterwards. Between the higher level sensor and lower level sensor, we need a 5x2 direction control valve. This is the 5x2 direction control valve. Now similar to these two, this 5x2 direction control valve is also pilot operated, pilot return. Pilot operated, pilot return. Okay. One is connected to compressor. One is connected to compressor. 3 and 5 are connected to exhaust. In the exam you can draw as many compressors as you like. It doesn't matter. It doesn't matter that all have to be connected to the same compressor. This makes reading the diagram easier. Okay. Okay. So the first thing you do whenever you draw these lower level sensors, make sure the lower first one should be to the left and lower second one should be to the right. Lower first one is to the left, lower second one is to the right. Connect the output of the lower left to this, connect the output of the lower right to this. Okay, done. We have managed the group switching part. Now we will have a look at this again. Okay, see what is B0's function. B0 is just used to switch the groups. B0 is just used to switch the groups. As soon as the group is switched from group 2, it is going to group 1. What is happening? A plus. There is nothing in between. As soon as the group is changed, what is happening? A plus. So directly the left side output should be connected to A plus. Now see which part of this is actually doing the A plus part. See, air is in this position, air is coming from here, it is going to the right side. It is going to this side and it is pushing the piston inwards. So in this position, the piston is going in A minus position. So just to make it clear, we will write over here A minus. And look, if it is in this position, what will happen? Air will come from the compressor. Air will come from here. It will go to left side. It will go to port number 4. It will go to over here and the piston will come outwards. So this will become A plus. Okay, so you have your A plus, A minus. Similarly, this one will be B plus. This one will be B minus. Done. Okay, so as I said, what is B0 doing? B0 is switching the groups, and as soon as the group is switched, what is happening? A plus. So B0 is to your left side. Connect the left side part to A plus. Connect the left side part to A plus. After A plus, what is happening? B plus. But between A plus and B plus, which sensor is being used? A1 sensor. Between A plus and B plus, which sensor is being used? A1 sensor. So what we are going to do over here? We are going to place the A1 sensor. A1 sensor is doing what? A1 sensor is doing B plus. So the output of A1 sensor will go to B plus. Output of A1 sensor has gone to B plus. Number 3 port will be connected to exhaust. but the number 1 port will not be connected to a compressor. The number 1 port will be connected to this number 4, the same port which started this group. So we will connect this to this line. Okay, see, this is the most important part of this circuit. You have to understand that number 1 is not connected to a compressor. The higher level sensors port number 1 are never connected to the compressor. They are always connected to the group power source, group air source. Okay, so this is where it is connected. Similarly, now we have completed B plus part. We have completed A plus, B plus. Now see, after B plus what is happening? A minus is happening. But between B plus and A minus, there is what? There is a group change. So group change is taken care by lower level sensor. Which lower level sensor? B1. So we have already made that circuit. B1 is changing this. Okay, it is placed on the right side. Now see, after B1, what is the immediate thing that is happening? A minus. It is happening immediately. So directly connect this number 2 to what? A minus. Directly connect this to A minus. Okay, so you have directly connected this to A minus. See, there is no connection over here. These two are jump. There is no connection over here. If there is a connection, it is shown by this kind of a point. There is no connection over here. Okay, so 2 is directly connected to A minus. After A minus, what is happening? B minus. But between A minus and B minus, which is the sensor used? A0. So we have to do B minus. But before that, we will have to use this sensor A0. So A0, 3 will be connected to exhaust, 2 will be connected to B minus, but 1 will be connected to the group power source. The group power source. The group 2 power source is number 2. The group 1 power source is number 4. Okay, so this is done. With this, your primary circuit is complete. Now let's see the animation. See, if we turn this on, see, A plus, B plus, A minus, B minus. But now see the problem. We cannot actually control the motion. As soon as we start the compressor, the pistons will keep on moving. If we want to stop the piston motion, we will have to stop the compressor itself. This must not be the case. So we have to put in a switch also. Now where will the switch be placed? We cannot place the switch in between. The switch should always be placed at the start. So we will need a switch. Okay, we will need a switch, and this will go to A plus. So A plus has two inputs. It has B0 also, switch also. These two will be placed in series to each other. Now a switch is also same as a limit switch. Okay, the normal switch that we used, it also has this same kind of symbol. So it will also use a 3x2 wall. But the only difference is, rather than using this symbol, which is for a limit switch, we will be using this symbol. This is for a switch. This symbol is for a switch, and this symbol is for a push button. In this case, we need a switch, not a push button. So I'll put a switch, spring return. Okay, I'll put it over here. We will remove this compressor. We'll connect this to this. 3 will be connected to exhaust. 1 will be connected to compressor. Okay. Now even if you start the circuit, the pistons will not move. The pistons will stay stable. But once you press this switch, the pistons will start moving. Okay, I hope you have understood this. I don't know, I have tried my best. So let's see. I have given you notes. You can always see this answer directly and try to understand what is happening. I have tried explaining. So best of luck for tomorrow.